Okay, good evening, everyone. My name is Robin Garrow. I'm Vice Provost for Graduate Education, Dean of the Grad Division, and I'm super excited to welcome you here for the final round of the 2018 UCLA Grad Slam competition. Tonight, we will select outstanding speakers and UCLA's winner, and that individual will go on to compete for the title of UC Grad Slam champion. Grad Slam showcases our extraordinary grad students, giving you a chance to learn about their innovative and impactful research. Whether you're a student who's presenting today, a member of our judging panel, or an interested observer, family, or friends, we appreciate your coming tonight to support our brave and brilliant scholars. This is our fourth year. The competition was inspired by 3-minute dissertation or 3-minute theses, sometimes called 3MT competitions around the country, started in the UC at Santa Barbara and Riverside and UCSF, and now it's a system-wide thing. This year's competition, we had 4 preliminary and 2 semifinal rounds. Altogether, 57 competitors representing 30 areas of study. About 3/4 of the students are doctoral students. Most of the rest are working towards a master's degree. May I ask this year's finalists, as well as all the students who participated in the preliminary rounds, to please stand so we can applaud your participation. Thank you. Now, audience members, you'll find a list of all the participants in your program that you picked up. Tonight we have 11 finalists, 8 doctoral students, 2 masters, and 1 medical doctorate. Their mission is to articulate their research to us in ways that are understandable, compelling, and engaging in 3 minutes or less. We have a panel of judges here. I'll introduce them in a moment. They will score each presentation based on 7 criteria: clarity, organization, delivery, visuals, appropriateness, intellectual significance, and engagement. They will award up to 5 points for each category for a total of 35 possible points, and based on their scores, we will award prizes. Third place will be a $1,000 fellowship. Second place, $2,000. And first place, $3,000. And there will be an audience choice winner based on your votes. So we'll explain voting later. You will use your cell phone. If you don't have a mobile phone with you, we have paper ballots. Okay. Now, the first place winner gets to advance to compete in the UC-wide competition, 1 person from each of the 10 campuses. That will be on May 3rd in San Francisco at the LinkedIn headquarters. I want to take the opportunity to introduce the person who not only won UCLA's prize last year, but went on to bring home the UC-wide Grad Slam trophy. And that is Leslie Rithenjarian. So please congratulate her. So, no pressure, but I want to keep it. It's kind of like the Stanley Cup for grad deans. We don't have a lot of stuff like that. So before I begin, I'd like to recognize our Grad Slam co-sponsors, the UCLA Student Fee Advisory Council, also known as SFAC, the California Nanosystems Institute for hosting us today, and Startup UCLA. So appreciate their support of Grad Slam. I want to also thank and acknowledge the core team that did all the behind-the-scenes work and the front-of-the-scenes work today, leading up today. Sonia Gavin, Latricia Rogers, Jackie Suero, Brent Sharman, Pete Clois, Kevin Tran, and Sophia Bautista. So thank all of you. Appreciate that. So they're here and here and around. Your program acknowledges the more than 200 people and departments that helped make this competition possible. It's a village. It's a city. Many of those people are here tonight working the scenes in various places, so thank all of you. Also want to acknowledge a distinguished guest tonight. We have with us Dean Linda Sarna from the School of Nursing, so thank you for coming. Now I have the pleasure of introducing my co-host, Michael Skiles, who's going to go over some of the details about the competition. He is a doctoral student in the home stretch, if I may say, in philosophy. And he's in his second term as president of the Graduate Student Association. So, Michael, please turn.
Thank you so much, Vice Provost and Dean Garrell. And good evening to everyone here. On behalf of the 12,500 grad students at UCLA, I'd first off like to congratulate all of our extraordinary finalists on the terrific achievements that have brought you here tonight. So many grad students are doing amazing research that will revolutionize their fields and make our world a better place. And yet, often only their advisors know about it. So thanks to all of you for coming out here tonight to give these students some of the recognition that their work deserves. We are also very happy that family members and friends who cannot attend tonight are able to view the competition via our live webcast. We've got a great camera in the back. And for those of you who use social media, please tweet, Instagram, Snapchat, Facebook, or whatever it is, otherwise you do away. And please use the hashtag UCLA GradSlam and GradSlam, as discussed on the screen. As you see here, we've got a clock set to 3 minutes facing the presenters. There will be a 10-second countdown to cue each speaker to start at the end of 10 seconds. If the speaker goes beyond the 3-minute limit, points will be deducted from the final score, beginning with a 1-point deduction at 3:03, and 1 point being taken off for every 2 seconds. The speaker continues after that. So presenters, if you reach 3 minutes, stop talking, because basically you've got a 2-second grace period before points start coming off. Between each presentation, the judges, who are seated in the first row, will have about 3 minutes to complete their scorecards. During that time, I will be talking to each presenter so we can get to know them a little better. During the reception, some presenters were asking me, what are you going to ask us? Seemingly concerned there was going to be an interrogation. Just a little bit. And then after the last presenter, we will have a quick 10-minute break while our tabulations committee, not from a big 8 accounting firm, totals the scores and determines the winners. During the break, each of you will be able to vote for your favorite presenter. You can vote by text or with a paper ballot. Even people watching online can vote. But please only vote by one method. Don't do paper and online. We don't want to have a Florida recount. During the break, you're also welcome to move around, network, and talk with our presenters. When we return, we will announce the winners, take some photos, and go back to the atrium for a celebratory reception with food and drinks. Now I'll turn it over back to Vice Provost and Dean Garrell, who will introduce our panel of judges and get this competition started. Thank you.
Okay. Judges who are not paid or compensated anyway, except maybe the swag bag, you have a very fun and challenging job. You are going to hear some amazing presentations about fascinating research, many different fields, and you heard the criteria. It's not about whether a student's going to cure a disease or land on Mars. It's about whether they're engaging, effectively presenting their research to our general audience. So you represent a general audience. As I announce your name, please stand, turn, wave to the audience and camera. I'll remain standing until I've read your names. Audience, you're welcome to hold your applause until I've read all of them. I'll start with Daniel Fruit, who's a professor in UCLA Department of World Arts and Cultures / Dance. Devon Graves, who is the 2017-18 Student Regent Designate for the University of California and a doctoral student in the Graduate School of Education and Information Studies here at UCLA. Melissa Efron-Hayek is the Director for Women in Philanthropy. Sonia Luna is the Executive Director of the California Nanosystems Institute. Anne-Marie Spataru is a Cabinet Member for the UCLA Chancellor's Society. And finally, Rhea Turtletab is Vice Chancellor for UCLA External Affairs. Thank you, judges. Really appreciate your commitment. And now it's time for the competition to begin. You ready? You ready? Our first presenter will be Cody House from Molecular Biology, a drug to prevent lung cancer.
Lung cancer. When we hear this, we immediately think of smoking. We all know the dangers associated with smoking, and we've made strides to create policy around its use. For example, right here at UCLA, we're a smoke-free campus. But what if I told you that 2/3 of people diagnosed with lung cancer today aren't current smokers? Lung cancer is not only the #1 deadliest cancer worldwide, but it kills more people than breast, prostate, and colon cancers combined. And of those diagnosed, only 1 in 7 live past 5 years. These staggering statistics tell us just how important it is to study this disease so we can identify new therapies. So this is why I study lung cancer, and today I want to tell you about the questions that my research is looking at. 1, why do we get lung cancer? And 2, how can we stop it? So why do we get it? Well, in a healthy lung, we have these mature cells with finger-like projections that are important for normal lung function. They help get rid of infection and harmful particles that are in the lung. We can see here the fingers of these cells working together to move this piece of debris up and out of the lung. Now, these mature cells, here in orange on top, they come from something called stem cells, here in blue on the bottom. And in my research, I found that when lung cancer first forms, these stem cells divide quickly and replace the mature cells. You can think of it as a precancer. And eventually, the precancerous stem cells divide so quickly and uncontrollably that they form a cancer that can spread across the body. Now, when most people think about treating lung cancer, they think about it at this stage. But by that time, it's very aggressive. So my research, it takes a different approach. What if we could target the cancer before it's aggressive? What if we could target the precancer? Is there a drug that we could give high-risk patients to keep their lungs healthy like this? We think yes. So in my research, I've created a model that mimics precancer in a dish. I've engineered the precancerous stem cells to glow brightly, and I can measure the intensity of this glow. And using this model, I screened for over 20,000 drugs. And I found one promising drug that decreases the intensity of the glowing stem cells by 85%. It makes them divide more slowly and helps make more mature lung cells again. We believe this work has tremendous clinical potential that can save lives. But you know, in the 3 minutes that we've spent together, another person in the US has just died of lung cancer. The devastating reality that these patients face needs to change. And I strongly believe my research can do just that. Thank you.
I just remembered I forgot my mic. Here we go. Sorry about that. Your slide brilliantly showed a petri dish. Is that where you've been conducting your experimentation so far?
Yeah, a lot of the experiments that we conduct are in a petri dish, and so we can grow the precancerous stem cells in this petri dish, and so that was sort of the basis for the drug screen that I talked about.
Well, very exciting. So obviously, if this becomes an available drug, could save many lives. Mm-hmm. What do you think the pathway between now and that is? And are you personally going to be working on that?
Yeah, so I mean, the sort of road that we envision for this taking, I think eventually, we would be interested in taking this to humans, of course, right? But I think before that, there are, of course, the process of clinical trials that I have to go through, safety, efficacy, those sorts of things. I personally will probably just be more involved with the science research aspect of it and not the clinical side of it.
Very cool. And then one more thing, if it's not top secret, what is actually going into the drug?
What's going into the drug?
Yeah. Like what's it made out of?
So the drug, we don't know what the ultimate, what the drug is doing per se, and so we've seen that it decreases the division of these stem cells, and so we're sort of moving from there to see, to better understand that, because I think it's a really good question.
Well, very good. Well, good luck.
Thank you.
And let's stop lung cancer from happening.
Agreed. Thanks.
Our second speaker is Yong Jun On from nursing, talking about saving lives with mindfulness practice.
What I'm about to share with you tonight will save countless number of lives, specifically people with high blood pressure, also called hypertension. We need normal blood pressure in order to pump blood through our body, but many of us have blood pressure that's just too high. As an emergency room nurse, I saw many people come in due to complications of their high blood pressure, and those complications include heart disease, kidney failure, and stroke. So it's not a surprise then that the World Health Organization refers to hypertension as the silent killer. And that's because for many of us, we don't have any symptoms until it's too late. Millions of people in the United States have hypertension. 46%. That's 103 million people. Treatment for hypertension is simple though. It includes a healthy diet and exercise, collectively referred to as healthy lifestyle. So let's get those 103 million people to make those healthy lifestyle changes. But you know and I know, in reality, most of us have difficulty doing that. My study addresses the difficult part by way of mindfulness practice, which is about bringing your focus, your attention, to the present moment. Now everyone, take a deep breath in and exhale. What were you thinking right before you took that breath? I'm hoping that everyone here was focused on this presentation because it's happening now. Mindfulness is unique in its ability to improve our self-regulation, which is our internal mechanism for decision making. And when we have better self-regulation, we tend not to make impulsive, emotionally driven decisions, like when I picked up my favorite candy bar earlier. To test out this model, my study recruits people with high blood pressure, randomize them to two groups, Mindful Wellness Program or the Health Promotion Program. Both groups receive information about healthy diet and importance of exercise. The only difference is the mindfulness group receive information about and practice about mindfulness practice, just like we did when we did the breathing exercise. This evening, I'd like to share some initial data from the study. And these are blood pressures that I've taken from the people who are enrolled in the study. Not one of these people with these high blood pressure readings felt badly or had any overt symptoms. What these initial readings do show is that the World Health Organization accurately describes hypertension as a silent killer. But I hope as people complete the Mindful Awareness Program that many will have blood pressure readings far below their initial reading and will continue with their healthy lifestyle practices and live longer. Thank you.
So thank you. Another great person seeking to save some of our lives. So let's talk about it. First, you said you're an ER nurse, is that right?
Yes, I'm an emergency room nurse. Well, I'm in school full time, but I used to be an emergency room nurse.
Okay, my first question was going to be, how do you find the time
to do this?
to do this research?
Yeah, I don't sleep, so there you go.
And how does not getting sleep affect one's blood pressure?
It goes up actually, because it's stress also, right? So yeah, everything actually causes your blood pressure to go up. So stress and lack of sleep.
Yeah, so obviously you've done some good research that has shown that mindfulness can bring the blood pressure down. How do you think mindfulness compares to other remedies people talk about, like, go get a dog, pet your cat, go for a walk?
Yeah.
Have you compared the significance of different interventions?
Yeah, that's an interesting question, because, and I chose mindfulness for its effect on helping people really focus about being aware and being kind of in the present. And I think that allows people to focus on their health more readily than some other interventions. There's some studies that show that people who do practice mindfulness tend not to choose unhealthy snacks like I did. So it's one more reason why I picked mindfulness.
So does this mean that you don't practice mindfulness?
Well, not at the moment when I picked up this candy bar, no.
Fair enough. And so for those who are thinking of practicing mindfulness, what are some other benefits aside from blood pressure?
One of the things that people have, my first cohort has told me, is that it really has like a calming effect. And the calming effect equals to less stress, which technically equals to lower blood pressure. So in all, I think it's beneficial. And UCLA has the Mindful Awareness Research Center. So, those classes are offered to the public. And we have podcasts and so on. So it's easily, it's accessible for everyone to practice.
Well, very awesome. Well, thanks so much for sharing your research, and good luck.
Thank you.
Thank you. Our third speaker is Marissa Stevens from Near Eastern Languages and Cultures, speaking about social identity from ancient Egypt to modern times.
Are you wearing? We hear celebrities being asked this question frequently on the red carpet. While seemingly a superficial inquiry into fashion, a celebrity's response speaks volumes about their style, professional connections, and wealth. And it's not just celebrities with carefully crafted images. People in general are concerned with how they portray themselves and, more importantly, how they are perceived by others. One way we build our social selves is through things we own and display to our peers. Part of our motivation to do this is to construct social identity, and part is to create social competition. I'm sure some of you wear a ring on your left hand to signal that you're married. That's social identity. And maybe on your drive here today, you saw someone behind the wheel of a Tesla while you were in your Prius. That's social competition. Materials help define who we are and who we are not. And my research aims to understand how individuals use materiality to construct social identity. But I probably don't study the types of objects you think. I study the funerary materiality of ancient Egypt. The Egyptians spent a lot of time preparing for death. Their tomb equipment included food and drink, furniture, clothing, jewelry, makeup, statuary, coffins, papyri. While the Egyptians believed that these items were necessary provisions for the afterlife, the interment of such items also acted as a form of social display and competition. Egyptian coffins, for example, were the same as that Prius and Tesla today. They both get you from point A to point B, whether that's from your home to UCLA or from this world to the afterlife, but it's the quality of the transportation that's key to that social competition. Now, my research specifically focuses on funerary papyri, like the Book of the Dead. Traditionally, Egyptologists only study these documents for their religious value, but their social significance is critical for understanding the people behind the papyri. Studying these documents, I recorded the names of over 500 Egyptians, plus details about their families, careers, wealth, and status. And by examining the content of the papyri, I even revealed the personality of each owner. My research brought back to life a group of Egyptians who lived 3,000 years ago and demonstrates that they too felt the same anxiety and pressure to navigate the social world as we do today. By learning from the past, we as a society are better equipped to understand our own motivations for constructing social identity through materiality. Thank you.
Thanks for the very exciting talk.
Thank you.
So, of course, now when we're going out and getting a Tesla or trying to rent the runway and stuff, we're trying to impress people while we're alive and among living people. Is it your contention that there's a goal on the part of the Egyptian upper class to impress people in the next life with how they arrive in the next life?
Well, yes, but the dead do not bury themselves, right? And so this is something for the living just as much as the dead. Their families benefited from the social display at the funeral, the living relatives, that it maintained their status in society or it extended their status in society. And for the deceased, it was incredibly important for them to have these material possessions. For the use in the afterlife and maybe to maintain that prestige in the afterlife.
Makes perfect sense. So, of course, in our society, we do display wealth as a symbol of status. In touching on the Tesla, we also try to display things like values, environmental consciousness. What were they trying to display aside from wealth?
Well, during the time period that I study and the papyri that I study, these are funerary documents. And one thing they're trying to display is their initiation into the temple and their knowledge of certain rituals and funerary texts. It was incredibly important for Egyptians to express the knowledge of their religion and show that ownership of that knowledge. And so that's one other thing that these papyri do.
So, in a way, it's sort of displaying their piety or their...
Absolutely.
Very good. And so, so you closed on how studying the past can help us to better understand these present displays. Do you have any application in mind?
Application? That's difficult. I'm not suggesting that we all go back to incredibly elaborate funerals, right, and spend all of this money. But I do think it's interesting to look at the materials that are left behind and try to understand if we do the same thing in our own funerary culture or if things are different. And I think in our world, we tend to go a little bit different. And so then the question becomes, why is that the case? And how do we understand our own status in society when we may not be placing those exact same values?
Very awesome.
So yeah, it's odd, but I always say that I think children normally go through a phase. That it could be an astronaut, it may be dinosaurs, and mine was Egypt. And so if you asked me when I was 7 years old what I wanted to be, I would have said an Egyptologist. And so I just always say I never grew up.
Well, good for you. And I think half of the PhD students in the room can relate.
Yeah, exactly, right?
Well, thanks for sharing your passion with us.
Thank you so much.
Hello, I'm Zach. I'm from electrical engineering, and these are some of the microscopes developed in our lab. This one counts blood cells and costs around $20. This one uses a cell phone and can actually measure the length of DNA, and this one can screen for prostate cancer. Now, we're very excited about these little things because microscopes save lives. And when microscopes can be low cost and portable like these, people all over the world can access their life-saving powers, specifically in poor or rural regions where the burden of disease is often the highest. Simply put, the world needs more microscopes and better microscopes. So to push our pocket-sized inventions to their limit, our lab has turned to a familiar source, the brain. Specifically, neurons and the complex interconnected networks they form. Networks that can actually change and adapt to learn a given task. So we asked ourselves if microscopes could be more like brains. Because after all, our eyes, which are a kind of microscope, work with our brain to form a clear image. So why can't a real microscope work with a computer to do the same? And in fact, in the 70s, mathematicians outlined a computer algorithm that mimicked the biological learning process of neurons. They called it an artificial neural network. And only until recently have computers been powerful enough to run this algorithm's vastly complicated math. So, for the first time, our lab has made a microscope that can learn. Using artificial neural nets, we taught a cheap, low magnification microscope to perform more like a state-of-the-art high magnification microscope. And we did this the same way one might teach a struggling student to improve their grades. We provided example problems and an answer key. Except here, the example problems are blurry images of a tissue sample taken with the cheap microscope, and the answer key are crisp images of the same tissue sample, but taken with the better microscope. And after millions of example problems, our microscope learned to ace the test on its own. It learned to take an out-of-focus blur and answer with a clear and crisp image. Now this is cool, because this means that an app on your phone can act as the brains for any number of microscopes around the world. This means a pathologist in a rural clinic can now make an early cancer diagnosis with a cell phone microscope because now they see more clearly the intricate details in a tissue sample like this. And that is most exciting of all, taking cutting-edge technology and putting it into doctors' pockets all over the world because microscopes save lives. Thank you.
Well, Zach, this is indeed cool. I think you, while everyone else is trying to think big, someone needs to think very, very small. So what do we think that the future of these sophisticated learning microscopes is? And how will we go from this technology to all being able to carry around microscopes we can use and enjoy?
Yeah, that's a great question. That's the most exciting thing, right? How fast can we implement this? And I think it's very close. The software that runs these algorithms can exist on a mobile phone and has been demonstrated to already. And the microscopes that we're using in the lab are easily scalable to be made in mass so that people can have access to them. So very, very soon, yeah.
Very good. So another element, you talk about the quality of the microscope and the blurriness of the image that comes from a lesser quality microscope. But if you think about the consumer with a phone, he doesn't want to get slides and put them in brackets
Sure.
and get the sample sufficiently moist. So is this same technology, could you potentially use it towards getting microscopes able to use the samples that people encounter in their daily lives, or is it a totally different problem?
Absolutely. So that's the goal. And I think these microscopes are actually fantastic educational tools with any kind of random thing someone might be curious to learn about. And this approach can certainly be applied to that type of thing. In our lab, the papers we published are specific to tissue samples, but the framework can be applied broadly to any sort of sample one might be curious to look at with a microscope.
Well, terrific. Another very layman's question. Can one both sort of zoom in and look microscopically? Like, could we ever get to a point where you're able to get your phone and like tell for yourself if you've got strep throat or just a cold, or is that like impossible?
No, absolutely. It depends on the problem. So there are fundamental physical limits to how small we can see with microscopes. But something like you said, where maybe you're looking at a relatively large object, which to me means like bacteria, this is very possible, yeah.
Well, very awesome. And so you're, of course, in grad school now. Where do you want to go? Do you want to develop this technology? Are you going to go into academia? What's your thoughts on the future?
Yeah, I would love to continue working with this tech. Right now, probably in academia. That sounds like a fantastic future for me.
Well,
yeah. So
academia.
All these sending resumes.
Well, we'll all vouch for you, and I'll go to your job talk. Good luck.
Thank you very much.
Thank you so much, Zach. Our next speaker is Taylor Corcoran from the Anderson School of Management, speaking about eliminating vaccine-preventable diseases with tailored immunization programs.
The red rashes of measles, the iron lungs and metal leg braces of polio. To most Americans, these diseases represent obscure maladies of years past. In many places, though, death from vaccine-preventable disease is a stark reality. Infectious diseases kill 3 million people a year, and the majority occur in developing nations. So this begs the question, why do some countries live relatively disease-free, while others are plagued by preventable disease? Well, in order for a country to be disease-free, a critical fraction of the population needs to be immune. And this fraction depends on the disease, as well as how effective the vaccine is. The more effective the vaccine, the fewer people that need to be vaccinated. Traditionally, governments have attempted to reach this critical fraction by vaccinating more people. But this can be difficult and expensive, particularly in developing nations, where infrastructure limits access to healthcare and can make vaccine distribution costly. Another approach is to increase the effectiveness of vaccines, because no vaccine is perfect. The flu vaccine is just 30% effective this year, and others require multiple doses over several years to ensure adequate protection. Unfortunately, this approach can cost billions of dollars in research and development costs. So given these challenges, what should governments do? Can we save more lives per dollar spent by using existing vaccines and increasing coverage, or by investing in the development of newer, more effective vaccines? Well, in my research, I developed a mathematical model to study this question. Among other things, I considered the contagiousness of the disease, as well as distribution and research and development costs. For any immunization policy, I can estimate the resulting number of infections and the cost. Then, using optimization techniques, I can identify, for any country and for any disease, which policy saves the most lives and minimizes costs. My results show that developed countries should focus on increasing coverage, while developing nations should invest in better vaccines because of high distribution costs due to poor infrastructure. So there's just one small problem here, and that's that many developing nations cannot afford this investment, even when it's the cheapest option. And that's why I'm currently expanding my model to consider alternative solutions, such as sharing costs across countries or using funding from global health organizations. We have the resources to end death from vaccine-preventable disease. And my model can help us learn how to use them most efficiently. Thank you.
Thank you, Taylor.
Thank you.
I feel like I've got a little bit of deja vu talking with you after Grad Slam. Thanks for coming back 2 years in a row.
Yeah, of course. It's good to be back.
So, I'm curious. A lot of this presentation seems like the sort of thing that maybe a public health student or public policy student could present, and very insightful. What did you bring from the business perspective to help this model?
Yeah, so certainly, and actually this work was partly inspired by going to a lot of seminars in the public health and the public policy department as well. But I think what, I'm in operations management, and I think what that really brings to this problem is using formal optimization techniques to approach these problems. I think like public health has a very good understanding of like what the problem is and how disease spread. But in terms of using optimization to understand how to best allocate our limited resources to solve this problem, that's where operations management comes in.
Very awesome. So when you talk about like cost sharing,
Yeah.
to what degree are you noticing that maybe if one country is just not able to deal with the problem at all, that results in higher rates of infection across borders and makes it to where it might actually be in other countries' interest to help them out in the long run?
Yeah, no, exactly. So I'm just starting to look at this. That's a newer part of our project, but certainly looking at like, you know, do other countries have an incentive to make sure that the countries surrounding them are well vaccinated so that cross-infection doesn't occur? So that's certainly something. But in terms, like, there's a lot of incentive issues, and how do you get countries to agree to cost share, and like, how do you hold countries accountable? And also for a lot of diseases, how do you get manufacturers and pharmaceutical companies to invest in some of these diseases when it may not be profitable for them?
Absolutely makes sense. And so as you've been doing this research, obviously it's the hardest thing to do is to say what to do, and there's not going to be a one-size-fits-all approach.
Yeah.
But can you point to like any policy where you're like, this clearly wasn't the way to manage it, everyone's been inefficient because they haven't worked together on this according to your model, where we could see how it could lead to a better outcome?
Yes. I mean, I certainly think like something that my work has shown is that in developing nations, really what we need there are better vaccines, because it's so hard to overcome the difficulties due to poor infrastructure. And how do you get people who are already nervous about vaccines to go in rural communities and get these vaccines for their children? So I think like sort of the approach that's being used in developing nations, which is just vaccinate as many people, isn't working. And so we need other solutions like using better vaccines so we don't have to vaccinate as many people. So that's certainly something that my work has shown.
Absolutely. And so, final question, do you have any words of wisdoms for anti-vaxxers out there?
I was actually wondering if this was going to come up. You can send them my way and I will talk to them. Yeah, no, I certainly think, I've certainly talked to people who have had really negative reactions to vaccines because they've like been injured by them in some way, shape, or form. But I think it's such a small risk, and especially like with any medical product, there's always a risk. But I think for vaccination, the benefits far outweigh the risks.
Well, I think mostly would all agree.
So.
Thank you so much for this
Thank
work,
you
too,
very
and
much.
so great to see you again.
Thank you.
Thank you very much. Our next speaker is Joey Lau from engineering, speaking about hospital-acquired infection, a little theme temporarily, the unknown killer.
In 2015, 2 patients from UCLA Medical Center died because of a contaminated scope. This, in healthcare, is known as hospital-acquired infection, or HAI for short. Now, you would think this is an anomaly, but it's not. Just this year alone, there are more people that are going to die from HAI than breast cancer and colon cancer combined. You have a 5% chance of getting an infection if you get admitted to a hospital here in the US. Outside of the US, it could be as high as 20%. Now, that's scary. So, don't get sick, and don't get sick while on vacation. Now, in the case of the UCLA incident, that instrument was sterilized on a machine similar to the one on the right. That's a sterilizer. And this is how the process works. When instruments are sterilized, a biological indicator, which contains a living organism, is included in the load. This is what a biological indicator looks like. After the sterilization cycle is done, this biological indicator is then put into a reader and is allowed to incubate anywhere between an hour to 24 hours. When the results come back as negative, that means the organisms in this biological indicator were all killed. That gives an assurance that the instruments were properly sterilized. Now, all of that matching of sterilization data with the results of the biological indicator, they're all done manually. Sterilization records are actually kept in binders in hospitals, which, as you can imagine, fairly inefficient and prone to human error. What if we can improve this process, which is the goal of my research? Working with other engineers, we developed this solution. This device, together with the software that we developed, allows these machines to talk to each other and share information. Information that we put in a database that can easily be accessed through a computer or a mobile device. Together with barcode information, it helps eliminate the confusion of whether a particular instrument was properly sterilized or not. This device can also monitor these machines. So if there is something wrong with the sterilization process or the machines, we can notify the hospital staff either by email or text so they can take the appropriate action. Look, our solution will not prevent the 98,000 HAI deaths that happen every year. But if we can prevent even one accidental death and help reduce the spread of infection in hospitals, then I believe the research that we put in to develop this solution is well worth it. Thank you. Michael, how are you?
Thank you. So I hope that we can finish this talk without people being afraid to go to hospital. So what portion of the infections that happen in the hospital do you think are a result of contaminated instruments as opposed to sort of just being in an environment where there's sick patients and
it's definitely in the double digits. It's not in the single digits. But unfortunately, there is not a lot of data that comes from hospitals, especially overseas. Actually, if you look at the data from overseas, they actually tell you, like in developing countries, that I mentioned it's as high as 20%, right? But in the surveys, obviously they don't want to show that they have a high infection rate in the hospitals. So if you look at actual surveys, it would be like in the 10%. But in reality, it's in the high 20%.
Yeah, and you know, it's relatively common, sadly, that when someone has a surgery, there ends up being some sort of infection as a result of the surgery.
Yeah, unfortunately, right.
Like, how much of the post-op infections do you think can be traced to some sort of contaminants either in the instruments or else in the room?
Yeah, so that's actually, so part of the solution, right, is it's hard to do that now because not a lot of the instruments are barcoded, for example, because it takes a lot of money, right, to do this, to track this efficiently. So there's not a lot of data, but we just know that, you know, overall, there's close to 100,000 deaths attributed to hospital-acquired infection.
Which is 100,000 deaths too many, to be sure.
Yeah.
So when these machines are going to be talking to each other and talking to technicians and texting doctors, hey, you need to clean up, is it going to be some sort of like chip in the instruments, or is it going to be barcoding, or how is the...
Right, part of it is the barcoding, and there's technology called RFID too, so you actually don't have to scan it. The challenge with a lot of these instruments, they're very delicate. So the typical sterilization method is steam, right? And so when you do that, the RFIDs don't last very long in steam. So that particular one is a low temperature sterilization, and more hospitals are using that. Unfortunately, it just costs more than regular steam.
Well, I think costs tend to be well worth it when they save you multiple more operations and potentially...
Yeah, you would think, right? Unfortunately, right, hospitals are run as businesses now, so they're always looking for that trade-off.
Well, terrific. So obviously this is not terrific.
I got it. I got what you were saying, though.
Please don't quote me on that. So
you gotta take that out from the video.
Yes, please do. So as far as solutions go, how much do you think this is part of the solution, or do you think that there's other avenues that we need to look
Actually,
towards?
education is probably the most important solution. One way to prevent infection is just to wash your hands, actually. So education comes a long way.
Well, that we need to do. And thank you so much.
Thanks, Michael.
I think your work is terrific.
Thank you.
And stopping patients from getting infections is terrific.
Thank you.
Our next speaker is Isaac Bryan from Public Policy, speaking about the price of freedom.
The money bail system exacerbates poverty. The money bail system is a punitive arm of our criminal justice system that's not rooted in public safety, but in affluence. Let me explain. If you are rich and you are alleged to have committed a crime, you can pay your bail in full to the courts and have it returned to you at the conclusion of your court proceedings. If you are poor, you are left with two undesirable options. The first, you can pay a percentage of your total bail in the form of a non-refundable bond payment. Or, and more commonly for the least of us, you remain incarcerated pre-trial, having never been convicted of any wrongdoing. As a lead researcher on the $1 Million Hoods project here at UCLA, and a student in the School of Public Policy, I recently had a chance to look at bail in a way that had never been done before in Los Angeles. Through aggressive negotiation, we acquired a data set from the Los Angeles Police Department that included all bookings from 2012 to 2016. Using this data, we totaled how much bail was levied in the city of Los Angeles from that time frame. It was $19.4 billion, or as we call it, the price of freedom. We then thought it was important to map where this money was being extracted from the community and where it was being levied. And so we mapped it by zip code. We mapped it by neighborhood. And I'm a policy student, so I mapped it by council district. And what we found was shocking. Council districts 8 and 9 are the council districts with the highest unemployment rates in the city of Los Angeles, and they are also the council districts where the most bail was levied. Coincidentally, they are also our blackest and brownest communities. We took it a step further and we wanted to find out how much of this was then paid in the form of non-refundable bond deposits. And what we found was that $200 million was paid in the form of those payments. 90 million of that came from Latinos in Los Angeles. 40 million came from African Americans. Think about that for a second. Bond payments are paid by those who can't afford to pay their bail. That means there's a cash extraction that's happening in our communities, our most economically aggrieved communities. And it's not going into public funds. It's propping up this private bonds business. And it's not keeping us safer. There are alternatives to this way of criminal justice. 6 states have done away with money bail. A county here in California has done away with it. Only the Philippines practices bail the way that we do it. From this research, I've made the normative claim that the price of freedom is way too high. But I would also argue that the price of knowing this injustice and failing to act on it is even higher. Thank you.
Well, that's a great argument, Isaac. We all want to pursue equal justice, and thanks for digging down. I know it was hard to get this data. If you're at liberty to speak, can you tell us a little bit about this aggressive negotiation?
So law enforcement agencies have a duty to make their data transparent, especially in response to a Public Records Act request. We face some resistance in that. And my mentor, Kelly Lytle Hernandez, here on campus, filed a lawsuit with the ACLU. And she was successful. And the settlement was about 30 variables of data. So we won big.
Well, good for y'all. So the question, I guess, largely is alternatives.
Yes.
Totally not fair that rich person who can easily pay, get all his money back, no problem at all, is given the same bail as a person who's going to have to stay until court hearing or else pay a huge bond.
Right.
Does having bail produce any measurable positive effects? Does it mean people are more likely to return or anything that could possibly justify it?
No. What it does is it exacerbates racial and economic inequities in society. The way bail is intended is to ensure that you return for your court proceedings. The thing is, we don't have a failure to appear problem in this country. 84% of people return to their court proceedings with or without bail. So it's a solution to a problem that doesn't exist.
You don't see it as a way of outsourcing to friendly neighborhood bounty hunters.
Yes.
That was definitely a joke. You bring up this problem of private companies, these bail bond holders. You know, they've now got a financial incentive to bring you in. They even make reality shows of it. To what degree do you think this private sector operates in a less just way than police attempting to offer justice could?
Because it's a private agency that's selling a commodity, I would argue is a commodity, and that commodity is freedom, there's a demand that's not influenced by natural free market causes. And in this country, if we know the historic roots of policing and incarceration, we know that there are racial and economic components that drive who's incarcerated and swept up by police. I was once recently outside of Men's Central Jail here in Los Angeles, and I was outside and there were 12 bail bonds agents in one shopping center. And I thought to myself, I was like, you couldn't put 12 Starbucks here and they would all be doing well. You know, there's something unnatural about this to even a capitalist society.
Well, I think that you've struck a very good moral tone here in the audience, and I think a lot of people are inclined to agree with you. While you got the floor, you've been studying this.
Yeah.
What other injustices do we need to eradicate in the criminal justice system in 60 seconds?
Solitary confinement comes to mind really quickly, and when you mix that with bail in particular, you have individuals, I think of Khalif Browder in New York, who was incarcerated pre-trial because he couldn't afford bail. It took over 3 years for him to be acquitted on all charges of stealing a backpack, but in that time frame, he spent 400 days in solitary confinement. When he was released, he ended up hanging himself at his mother's house. So solitary confinement is the first that comes to mind, but there's a lot of work that needs to be done. And I think there's a will nationally, I think there's a will locally, and I think if we know these injustices, that we'll act.
Well, thank you, Isaac, and I hope you keep fighting for justice. Our community needs it.
Thank you. Our next speaker is Viola Ordini, speaking about what are fairy tales.
How many of you, as children, read fairy tales before going to bed? I did. As adults, we also read and watch remakes of the same fairy tales. So, what are fairy tales? Fairy tales are stories that travel across time and space and find their life in books, films, theater plays, paintings. Because here's something crucial about fairy tales. They always repeat themselves, but they never die. Think about Beauty and the Beast. It exists in a 16th century Dutch painting, a 19th century French novel, a 20th century Russian ballet, a 21st century blockbuster movie. Same beautiful woman, same beast, same initial fear turned into a happy ending. But why does each repetition express the same fear of those we do not understand, like the beast or the creature in the shape of water? Some scholars answered looking at recurrent plot turns. I propose, however, to look at metamorphoses of fairy tales across the board and to metamorphoses that happen within each remake. My project is about repetition of fairy tales like Beauty and the Beast and The Love of the Three Oranges. I do close readings of texts to grasp the deeper meaning of formal and bodily transformations or metamorphoses. I found a connection between recurrent changes of shape of fairy tales and the repetition of intolerance and exclusion of diverse subjects like animals, women, slaves, persons of color. In the adaptations of The Love of the Three Oranges, catered both to adults and children, a woman who was formerly an orange wants to marry a man, but a female slave of color pretends to be her and tricks him. This slave is always condemned to death. Also, she's always subject to mocking because of her bodily shape, both verbally and visually. For centuries, this problematic story has touched on dynamics of intolerance and exclusion deeply ingrained in our cultures, yet it has been told and retold. My research invites all of us to reconsider fairy tales as moments of education, comprehension, inspiration for a society where intolerance has no place. What are fairy tales? Stories that shape society while changing shape. Thank you. Hello.
Hello. Exciting tale. So, of course, we know that fairy tales are tales as old as time, and you could even say songs as old as rhyme.
Yes.
How have fairy tales changed over time, particularly with respect to tolerance? Is there any sort of progression?
So that's a very, very big question because they have changed in many ways, basically. They have changed for the way we tell them because back in the day they would tell them just orally. They have changed in the place we tell them because they're told everywhere, literally on Earth. And they have changed for the audience that they have. And also they have changed for the purpose that we tell them. Since the 19th century, we mainly tell them to children for moral purposes or educational purposes. So what I found particularly worrisome was that despite this repetition over time and the change of our values in terms of tolerance and non-exclusion and inclusion of diverse subjects, well, some patterns remained. And so I ask why? Why do we keep repeating but we don't change that very problematic thing? Maybe because they tell us something about ourselves that we don't want to admit?
Yeah, so if you've been following, say, Disney stories over the last 10 or 15 years, a constant push has been to make sure that certain races are represented as princesses or, different sexual orientations, trying to make sure that this isn't just a show for the white. But what other changes do you think we should make in the fairy tales we tell?
So I don't want to say that we shouldn't read or we shouldn't tell fairy tales because I find it interesting that we can read them and find the problem. But I think a change that could be done is in the way we tell them because Disney is really good in embracing on the surface whatever we are thinking that it's really important to embrace. But the way you narrate them, the words that are used, the rhetoric, the plot structure, the character development, can be deeply changed. And that's an artist that can do that. So Disney needs to hire more artists that can do that.
Well, I hope they hire you as a consultant.
We'll see.
And so supposing they get it right, supposing they stop doing the things that contribute to stereotyping and injustice, and we start having good fairy tales, how much of an engine do you think fairy tales could be for positive social change?
First, I'm not sure we can ever do that because as human beings, we cannot really get rid of the things that scare us, like people that are different from us. But if we are doing that, well, I guess that's a perfect world. If stories are perfect.
Right. And so if you could leave the audience with a suggestion, one fairy tale you like and you'd like us to look into that's maybe at least getting some of these things right. What's your favorite?
Well, I really like Bluebeard, but it's not really the best fairy tales to describe what I just said because it's really grim. It talks about this man that kills a lot of women, and then a woman finds out, and she escapes, and he dies.
Perhaps.
But you can read it. It's like many versions are really, really high literature, I think. So.
Well, thank you so much for sharing these stories, and good luck.
Thank you so much.
Thank you. We're in the home stretch. 3 more awesome presentations to go. Our next speaker is Joseph Friedman from Public Health and Medicine, the shocking social patterns of prescription drug use.
This year, in Malibu, Beverly Hills, and right here in Westwood, 1 out of every 3 adults will go to a pharmacy and fill a prescription for Xanax or another benzodiazepine used to treat anxiety. But just a few miles south, in Compton and Watts, that number falls to just 1 in 20. A pattern this stark jumps right off the map, and it begs the question, what could possibly account for a 7-fold difference in a basic medical treatment between 2 neighborhoods in the same city? This pattern was really hard to explain until we put it next to a map of racial composition in Los Angeles and saw that the 2 patterns are essentially identical. So I became interested in this research question because, like many of you, I'd heard a lot about the epidemic of prescription drug abuse. And because my background lies in using big data to answer questions in public health, I decided to do some investigating. And what we found was shocking to me. I would like you to imagine that each of these colorful panels of boxes represents our society. So as you move up through each row, you're moving through whiter and whiter neighborhoods of California. And as you move to the right, you're moving through higher and higher income neighborhoods of California. So taking a look at stimulants in purple, which are usually used to treat ADHD, you can see that they're remarkably concentrated in the whitest and highest income communities in our state. And looking at opioids in blue, usually used to treat pain, you can see that they're very concentrated in the whitest and lowest income communities of our state. Looking at benzodiazepines in green, usually used to treat anxiety, you can see that income doesn't seem to be that important of a factor, but like we saw earlier in Los Angeles, they're very concentrated in the whitest neighborhoods. So we know that these patterns do not reflect equality, right? Because we're not seeing that these medications are being distributed equally across different social groups. But you might ask, could this reflect equity? Is it possible that some groups simply have a greater need for these medications and so they use them more? Unfortunately, all of the evidence points to the contrary, that actually the groups with the highest rates of chronic pain and mental illness have the least access to these important medications that can help their symptoms. And so, while we've all heard a lot about this epidemic of the abuse of these prescription medications happening in some communities, which are mostly white, maybe we haven't been hearing enough about this other epidemic of untreated chronic pain and ADHD and anxiety that's co-occurring in the same society, but in different communities. Thank you.
Thank you. So we definitely want a society where everyone's able to watch the ball game. Sorry that we're not there. So we've established a very, very strong correlation, I think. What do you think might be the causes behind those correlations?
Yeah, thank you. That's a really good question. So, I mean, each of these drugs has this rich social history that's led to these patterns that we see today. So, and really there's so many reasons, but I'll give you a few examples. So, for example, for opioids, there's a lot of evidence that many doctors who don't consider themselves to be racist or hold any kind of prejudices, you do simulation. and you give this patient a set of symptoms, and then you change the race, and all of a sudden, the same physician finds themselves only half as likely to prescribe an opiate for the same kind of pain. So these are implicit biases that are in all of us. There's other things like the way that pharmaceutical companies have specifically marketed certain communities. So for example, OxyContin, there's been a lot of press recently about how they're being sued for a very manipulative way that they targeted physicians and tried to promote their medication, which is turned into this huge social problem. But actually, they specifically went for low-income white communities when they marketed these medications. And many scholars feel that the reason they did that is because they wanted an audience who they could kind of capture for a longer time before society intervened.
So what do we think solutions might be? Is it training people to root out implicit biases? Is it more equitable marketing? What suggestions might you have?
Yeah, so I think one thing we can do is be aware of implicit biases, but the most important thing here is just about access. I mean, in order for you to fill a prescription, you have to have health insurance. You have to get time off of work. You have to go in and make it to see a provider. They have to trust you enough to give you this medication. There's all of these factors that go into it. So I think we have to take a step back and say, who are the people who do and don't have access to healthcare in our community? Like, for example, in Los Angeles County, there's almost 1 million people who are undocumented. And those people have very, very poor access to healthcare in general, to health insurance. And so we have to think about, maybe that has something to do with the reason the map looks this way.
And so given that there seem to be these huge disparities in access, which are disturbingly on the basis of race and income, should we look to quicker solutions, like maybe having more drugs available by non-prescription, or is that a recipe for disaster?
Yeah, I'm as a medical student, I think the answer I have to give is let's stick within the medical system and let's move towards a place of greater equity in the existing medical system that we have.
Which, I mean, I could see why we might cause more of an opioid epidemic if they just went OTC, but over the counter. What education would you suggest be given to med students, to residents, to early providers to try to get them to be more equitable in their diagnoses? Any thoughts on that?
Yeah, that's a really good question. I mean, I think that part of this is about changing the tone in what is the kind of basic set of information that we teach about diseases. So I've actually been involved in some efforts related to the medical school curriculum because a number of students, we feel like anytime we learn about a disease, we need to know about the social context because these are the patients that we're going to be serving. And so often, I've been reading all of the high-profile articles about the opioid epidemic, and people don't talk about race, and they don't talk about income. And it's just sort of all this information in the background that I personally feel, I mean, I'm biased because I do social epidemiology, but I feel like we need to really bring that to the forefront in our discussions of these topics.
Well, thank you for raising awareness of this, and I hope that it leads to good change.
Thank you.
Thank you. Our penultimate speaker is Preana Punuscue from chemistry, speaking about novel materials for sustainable food security.
If we continue the agricultural practices we use today, we will not have enough food to feed the world by 2050. In fact, it's predicted that we will need to increase food production by 70%. And to make matters worse, many of our current high-yielding practices are degrading and polluting our environment. There isn't one solution to all of our issues, but by refining individual practices, we can hopefully make a cumulative effort towards food security. Today I'll be talking about my work towards a solution for a prevalent problem in one of the most destructive sectors, the livestock industry. Currently, cheap grains like barley are used to feed animals, and while this is cost efficient, many farm animals can't easily digest these crops. This limits their access to nutrients, and undigested food and animal waste contributes heavily to land and water pollution. A known solution to this is to add enzymes to animal feed. Enzymes are like biological machines, and they help accelerate reactions in living organisms. In the case of animal feed, adding enzymes helps break down feed faster so that animals can access all of their hidden nutrients. And here's the problem. The sterilization of animal feed requires temperatures as high as 200 degrees Fahrenheit. Many enzymes are destroyed at these temperatures, making them inactive so that they can no longer break down feed and ultimately leading to the same issues we had before. Genetically engineered enzymes can be used in this process because they can survive higher temperatures, but making them is expensive and tedious. My research focuses on developing an easy method to stabilize enzymes that's both economically and environmentally viable. It all boils down to the use of a miraculous sugar, trehalose. Trehalose is actually naturally produced by organisms that need to survive extreme environments because it can protect cells and proteins. In this same way, trehalose can protect enzymes. I create gel materials that incorporate trehalose into their structure. The gel part of the material makes it easy to trap enzymes so they're completely surrounded by trehalose, which protects them from high temperatures. So much so that an enzyme that might otherwise be non-functional after being heated to 200 degrees Fahrenheit is able to survive with 100% activity if it's heated within the gel. Animals can then safely consume the gels, and the enzymes can easily escape to break down feed in the digestive tract. This keeps our feed costs low, makes our animals happier and healthier, and reduces pollution. Now, this isn't going to solve all of our food security problems, but it's definitely a step in the right direction. Innovative solutions such as these materials can collectively create more sustainable agricultural practices. And together, with changes in policy and individually wasteful habits, hopefully we can feed our growing population in a way that's not destructive to our home planet. Thank you.
Thank you. Like the picture of the pig.
Yeah, it goes really sad to really happy.
Yeah. So what happens if humans ingest animals that have ingested these gels? Do these enzymes go into us?
Yeah, so as far as the enzymes, they would be excreted eventually, but as far as the gels goes, those should be excreted as well, but I haven't done those studies. There are industries that are really interested in these gels, and they will be doing those studies to kind of see like where that will actually end up. Yeah.
Makes good sense.
Yeah. And we also actually, we have some of these enzymes in us because we can break down those kind of things. So it wouldn't be like harmful to us or anything if we had them. If anything, it might be helpful for us to have more of them.
Yeah, so that's what I was going to say. You know, a lot of people are taking digestive enzymes all the time, particularly lactose intolerance.
Yeah, absolutely.
Folks take lactate. I mean, could getting some of this be helpful to humans, at least preliminarily?
Yeah, so I've actually thought about this a lot, and not to be super grim, but I do think we clearly have a food security problem, and eventually we might end up having to eat things that maybe we don't really consume now, and we can't break down very well, and we could use this technology on humans as well. Yeah.
And so in dealing with the general food security problem, it's sad to a degree that animals are being fed things that maybe they're not naturally inclined to eat.
Yeah, absolutely.
Do you see this as a better approach than just grass-fed beef?
Right.
Or
absolutely. So for me, I'm actually a vegetarian, which is the best part about this. So the easiest problem to me is like stop eating meat, right? And then we won't have as many issues with pollution and costs. But as far as the animals go, I think that would be really viable in maybe like societies that have a little bit more money so that they can actually feed animals healthier things that they can actually break down on their own. But I do think that's more of a privilege thing, and as far as poorer nations, they might not be able to provide that kind of nutrients for animals to feed their people. So this is really just a good way to hopefully help everybody in doing that, but hopefully eventually we'd also be moving towards, and that's why I mentioned like policy and individually habits, individual habits, we'll move more towards eating less meat and hopefully feeding our animals better. But this is definitely like a if you can't beat them, join them type approach. Yeah.
Fair enough. So we're all clear. She's not actually endorsing eating meat.
No, but I mean, I do think that's my own choice, and I don't think everyone should actually stop. But I do think it's something that we always need a solution, and even if meat production and meat consumption doesn't keep on going up, we still need technologies like this. Yeah.
And so, you know, throughout history of the last couple hundred years, all the way going back to Malthus, you've had a lot of people sort of freaking out. Populations exploding, food supply is not going to be able to meet the demand, and then technologies have saved us for the most part so far. How confident are you that that's going to be the trend, or are you starting to really worry?
I think we have a really good way of saving ourselves even when we get to a point of crisis. And I really think that through science and technology, and then also implementations of policies and people kind of digesting this material, no pun intended, sorry, digesting this material and hopefully changing the way that they also eat and do sustainable practices, I do think that we'll be able to overcome this. I feel very strongly about that, yeah.
Well, very awesome. Well, thank you so much for making not only the pig, but all of us happy with your talk.
Yeah, thank you.
And good luck.
Thank you.
All right, we're at the last talk. Please join me in welcoming Preana Punuscue from Bioengineering and Medicine, speaking about wireless, batteryless miniature cardiac pacemaker.
In the past few decades, the tech world has been obsessed with the idea of making things smaller. The first computers filled up the whole room, and it didn't really take us long to make it fit on our desk, and it really didn't take us long to get it to fit in the palm of our hands. Well, alongside this trend, our generation has also been familiar with the idea of cutting the cord. Now, I know we usually associate that with getting rid of our cable bill, but cutting the cord has actually been in many aspects of our lives, from getting wireless phones to taking that tangled mess and turning into this sleek little device. And we've also been introduced to the idea of wireless charging. Well, interestingly, the world of healthcare has actually been moving more or less in the same direction as consumer electronics. Highlighted in yellow, we have the first pacemaker. A pacemaker is a device that helps maintain the heart's rhythm for the millions of patients whose hearts would fail without it. Now, as you can see, in that first pacemaker, it's this big, clunky device with wires hanging from outside the body, going through a hole into the body. And yes, it was as painful and unsanitary as it sounds. Thankfully, we've come a long way since then, and we're actually able to fit the whole pacemaker inside the body, which is what you see in hot pink right there. So the problem with that is we still have a lot of wires that go through our vessels, which can be very dangerous, which is why companies have tried to come up with solutions, which brings us to the latest in technology highlighted in green. Unfortunately, this device can't actually be used by over 90% of patients, and it still carries many of its own problems because it has to have an integrated battery. Now, my device tries to remedy all these problems by getting rid of the battery. And you can see what it looks like, highlighted in beautiful sky blue. And so how did we get here? How were we able to miniaturize this so much? Well, we developed a new design called intermittent remote stimulation, which we were able to achieve by taking all these components here that take up so much space and power that are usually placed on the heart, and we actually put it into a wireless transmitter. Now, trust me, it's a lot harder than it sounds, but we've been able to make it happen. In fact, our successful animal studies prove that we're not making this up. So while going wireless and miniaturizing our systems is just really cool and exciting in the world of consumer electronics, in the world of healthcare, it can mean the difference between life and death. Thank you.
Well, thank you for that great talk. On the subject of cutting cords, I mean, we can see some practical benefits. I mean, if I pull out my own, I mean, it's probably going to take at least 3 minutes to untangle this whenever I need to make a call. You showed these pictures of these AirBuds or earbuds or whatever they're called. We're all moving in that direction. What benefits do you think this will offer to cardiac patients? How will this make them able to live their lives better?
Yeah, so right now, most pacemakers have essentially those wires that go through the vessel, which actually they cause a lot of complications. So 10% of patients experience complications, which cost the healthcare a lot of money, and it costs the patient money, and it's risky to their lives. So getting rid of those wires is really helpful in trying to help save patient lives as well as save the healthcare system a lot of money.
Well, I can certainly see that. And so as we are looking now, how long do we think that we can keep pacemakers powered this way, and how does that compare to the other options?
So pacemakers have been like this for almost 50 years. The technology that I showed you that companies are currently using that doesn't have the wire, that was just FDA approved about 2 years ago. So it's very exciting that we're going towards that direction because the industry knows that this is a huge problem. But like I said, it only goes into 10% of patients, and even they have complications. So it is really important that we move towards something where patients don't experience these problems.
Absolutely. And so what got you in particular excited about wireless, batteryless pacemakers?
Well, I've been really interested in the heart in general for a long time. I think it's a very interesting organ. And I worked on pacemakers in a company before. And I kind of realized the problems that exist, and I wanted to find a solution for them. That's how I got here.
Well, certainly an exciting journey, and I wish that you could have spoken first because you would have set a great pace for the rest of our evening. But a great note to end on.
Thank you.
Thank you. Please join me in giving all of our students a round of applause and congratulate them on their work. You know, I just feel so proud of what you've accomplished, your commitment, your energy, your intellect, your commitment to tremendous scientific, health, social problems. Bravo, congratulations. We can't wait to see what you do next. And thank you so much, Michael. You were awesome yet again. And if that academic gig in philosophy doesn't work out, you have an alternative option. Just saying. No, look, I'm just kidding, of course. Now we have one more thing before you take a very short break, because I know our team behind the scenes is already busy doing its hard work. Now's the time for our audience choice voting. So may I ask you, please turn your attention to the screen. Take out your smartphones if you have one. If you don't, it's okay. You kind of get the idea, and we'll have some paper ballots for you. If you follow the instructions, you get to vote once for your favorite speaker. You only get to vote once. You can't take it back. I know it's hard, because you look back and say, oh, that was awesome. Oh, that was awesome, too. Yeah. Now, if you don't want to vote by phone, and if you're having technical difficulties, you can't get a signal, your battery's dead, you can vote using the ballot and pencil you may have picked up on your way into the auditorium, or there'll be more on your way out if you missed that. As soon as you're done, please return your completed ballot to one of the blue boxes just outside the auditorium. So if you walk out, grab a ballot, write it down, put it in right away, because we're going to count. Once you place your vote, you can chat, take a bio break. We're going to take about 5 minutes. We don't need 10. So 5 minutes. We're going to have a reception, all that stuff out there, so we don't get caught too much up in the food and stuff. So we're going to do the awards, and then the food and drink and party and all that good stuff. So about 5 minutes. So do this, stretch, take a few minutes, and we will call you back verbally. There'll also be some people rounding you up in the lobby. So no, don't vote early and often, vote once. Okay, I'd like to welcome you all back to the auditorium. So welcome back, everyone. We're going to actually get started by acknowledging and celebrating all of our grad student contestants by presenting each of them with a Grad Slam 2018 finalist certificate. Very fancy thing. And they will each receive a $100 credit on their Bruin card. It's something. So I'm going to welcome Associate Dean Joe Watson to the podium to announce the names, and Michael to join me on stage to present their certificates. When Joe calls your name, folks, please join Michael and me on the stage to get your certificates, stop for a photo, and then return to your seat, if you would, please. So, Joe, it's all yours.
Hello, everyone. Our first person who will get a certificate is Preana Iberia. Our second person will be Yong Jun On. Third up is Viola Ordini. Next is Cody House. Zachary Ballard. Bryan. Next is Taylor Corcoran. Joseph Friedman. Next, Joey Lau. Next up, Preana Punuscue. And last but not least, Marissa Stevens. The next part's not on my script. What's going on?
I'm waiting for information. we're going to do the Audience Choice Award.
Okay, well, good audience. Audience Choice Award is Zachary Ballard, Electrical Engineering. I get to do all of them. Okay. I thought I only got to do the Audience Choice Award. This is exciting. Okay, third place goes to Joey Lau, Engineering Management. Second place winner, Isaac Bryan, Public Policy. And the 2018 Grad Slam winner, Marissa Stevens, Near Eastern Languages and Cultures.
So excited. That concludes our formal program. Awardees, please stick around. We're going to capture some individual pictures from you here on stage, just for a couple minutes, and then head out. Judges, we're going to need photos of you too, so stick around just for a minute or two down here. Everyone else, please join us in the atrium. Thank you so much for coming. I hope you had a great time. See you out there.